So today we're looking at the factor theorem. Let's have a look at our first exercise. So we're asked, what is the sum and product of the roots for the following equation? So our equation is negative 2x squared minus 8x plus 13 equals 0. So we're asked to find the sum and the product of the roots. So let's have a look at the factor theorem, a statement of the factor theorem. So the factor theorem says x minus p is a factor of f of x if and only if f evaluated at p equals 0. Now the extension of the factor theorem is what we're going to need here. So we have a function, so a function f of x that has this form. So this is a form, if you notice, of a polynomial, a general polynomial. It has a factor q times x minus p if f evaluated at p over q equals 0, where, and this is the interesting part, q divides an and p divides a0. So what this means is q is a factor of the leading coefficient and p is the factor of the constant. Okay, and we also have that the sum of the roots, and this is what's interesting for us or useful, the sum of the roots is given by negative of a sub n minus 1 over a0. So the sum is the ratio or the fraction created by the coefficient of x to the power n minus 1 over the constant. And the product of the roots is negative 1 to the power n, so n is the degree of our polynomial, times a0 over an. So the constant over the leading coefficient. All right, so now let's keep that in mind and let's have a look at our exercise. So we're asked to find the sum and product of the roots of our polynomial here. Negative 2x squared minus 8x plus 13. So what is our leading coefficient? Our leading coefficient is negative 2, so this would be a sub 2. Our constant is a0, and that's 13 in our case. So let's have a look, because we'll call this f of x. That's our polynomial. All right, our degree, our n equals 2. Okay, so our sum, we'll go back here, the sum of the roots is negative a sub n minus 1 over a0. So what is a sub n minus 0 in this case? So in our case, that would be a1. That equals negative 8. So our sum, I think we have everything we need. So our sum equals negative of a, let's put it here, a sub n minus 1 over a sub 0. So negative 8 over 13, which equals 8 over 13, and our product equals negative 1 to the power n. Let's check. A sub 0, yes, put that right. A sub 0 over a sub n. In our case, n is 2, so negative 1 squared. A sub 0 is 13. And a sub n is negative 2. So this works out to be negative 13 over 2. Good. All right, so let's look at our next question. State all possible values of p over q that could make this polynomial or function 8 times x to the power 3 minus 7x squared plus 23x minus 4 equal to 0. Okay, so this is going to be a bit more challenging, but not impossible. So let's go back to the statement of our factor theorem. All right, so notice our factor theorem tells us that, or the second part, the extension. So here it tells us if we have a function that looks like a polynomial, it has a factor that has the form qx minus p. If p evaluated at p over q equals 0, where q is a factor of an, p is a factor of a0, or constant term. So we need to find the factors of our leading coefficient and factors of our constant term, and then take their ratio. Oh, all right, so let's go back. Let's do that. Okay, so what is our leading coefficient? So our AN is 8. So in this case, N is 3. And A0 equals -4. Okay, so what are the factors of A sub 3? Let's change that to 3. Good. Of our leading coefficient, our factors are 1 and 8, and 2 and 4. What are the factors of -4, our constant term? We have -1 and 4, 1 and -4, -2 and 2. Is that all we have? Yep. I believe that's it. Good. All right, so now if we go back to the statement for factor theorem, our factor for a polynomial has this form, qx minus p, where p over q equals 0, and p divides a sub 0, our constant term, and q divides our leading coefficient. So we need to look at various ratios, p over q. So all possible ratios p over q are going to give us values that could make our function, let's give it a name, f of x equal to 0. So p is a factor of a0, and q is a factor of a sub 3, our leading coefficient. So we'll just write out a few possibilities. So for example, if we take p to be -1 and q to be 1, this would be -1 would be one possible value that would make our function or polynomial equal to 0. What's another one? So let's take p equal to -2. And q equal to, say, 4. This gives us -1/2, so that's another possible root of 0 of our function. So in this way, we could take all possible ratios or fractions of p values, and q values to give us possible values p over q that can make our function f of x equal to 0. So I'm not going to state them all here, but I think given all the possible p values or factors of our constant term and all possible q values, factors of our leading coefficient, we can, I think if you work through it, you'll be able to find all the possible ratios p over q. Okay, so now let's look at the next exercise. All right, let's make it a little smaller so we can see the question. Use the factor theorem to determine if x minus c is a factor of f of x. So it looks like we're given c, and we're given our f of x, and we want to determine if x minus c is a factor. So again, let's go back up to the statement of our factor theorem. Looks like I put it up too high. So x minus p is a factor of f of x if and only if f evaluated at p equals 0. So it looks like we need to evaluate our function, our given function f of x at the value c. And if f at c equals 0, then x minus c is indeed a factor of our function f of x. So let's look at the first one. So f of x is 4x cubed minus 3x squared minus 8x plus 4. Our c value is 3. So let's do f at 3 and see what we get. So we have 4 times 3 cubed, let's just plug it in, times 3 times 3 squared minus 8 times 3 plus 4. All right, so 3 cubed is 27 27 times 4. 27 times 4 is 108. Minus 3 times 3 squared is 9 times 3, which is 27. Minus 8 times 3 is 24, plus 4. Let's see what that equals. So 108 minus 27 minus 24 plus 4. It looks like it's 61. Let's check that again. 108 minus 27 minus 24 plus 4, 61. This does not equal 0, so therefore x minus 3 is not a factor. Okay, so in this way we're going to go through the remaining exercises. So let's see if we can fit one more in here. Let's do number 2. So we're given a function f at x equals 3x to the power 4 minus 6x cubed minus 5x plus 10. C equals 1. So let's evaluate f at 1. And what do we get? We get 3 times 1 to the power 4 minus 6 times 1 cubed minus 5 times 1 plus 10. So we have 3 minus 6 minus 5 plus 10. This equals, I think that's 2. Let's check. Yes, 2, and that does not equal 0, so no, again, we do not have a factor. So therefore, x minus 1 is not a factor. Okay, so we're not doing very good yet. We haven't found any factors. Okay, let's scroll over and let's try number 3. Number 3, our function is 3x to the power 6 plus 2x cubed minus 176, and our c is negative 2. Okay, so let's put it here. So we need to evaluate it f at negative 2, and let's see what we get. We have 3 times negative 2 to the power 6 plus 2 times negative 2 cubed minus 176. All right, so negative 2 to the power 6 equals 64 times 3 is 192. And then plus 2 times negative 2 cubed. Negative 2 cubed is negative 8 times 2, negative 16 minus 176. So let's have a look at what that is. 192 minus 16 minus 176. And yes, we get 0. So therefore, x minus negative 2, which is x plus 2, is a factor of f of x. So great, we found one factor. All right, let's try number 4. Let's go over to the left here. So number 4, f of x is 4x to the power 6 minus 64x to the power 4 minus x squared minus 16, and our c is 4. So again, we need to evaluate our function at that value c. So what do we get? We get 4 times 4 to the power 6 minus 64 times 4 to the power 4 minus 4 squared minus 16. Okay, so let's evaluate this. 4 to the power 6, that's a big number. Okay, 4 to the power 6 is 4,096. Okay. Times 4, okay, it's a big number. That's 6,384 minus, okay, 64 times 4 raised to the power 4. 4 raised to the power 4 is 256 times 64. And look at that, we get 16,384 minus 4 squared is 16 minus 16. So the 16,384 cancels out, which is nice. Then we're left with negative 16 minus 16, which is negative 32, and this does not equal 0, so therefore x minus 4 is not a factor. Okay, so one more, number 5. So number 5, f of x equals 2x to the power 4 minus x cubed minus 2x minus 1, c equals negative a half. So this means, so you can see that, do we have space? I think we have space. Let's see if we can squeeze it in here. So f, we need to evaluate our function f at, what's our value? C equals negative a half at negative 1/2. So if we do that, what do we get? We get 2 times negative 1/2 raised to the power 4 minus negative 1/2 cubed minus 2 times negative 1/2 minus 1. Okay. All right, let's evaluate this. 2 times negative 1/2 raised to the power 4 is 2 times 1/16. Okay. Minus negative 1/2 cubed. That's negative 1/8. So we can write plus 1/8 times 2 times negative 1/2. Well, 2 negatives make a positive. Our 2's cancel out. We're left with 1. And finally, minus 1. Okay. All right. So 2 times 1/16 is 1/8. Plus 1/8. Plus 1 minus 1 is 0. So we're left with 2/8. Which equals 1/4, which is not equal 0. So therefore, again, x minus negative 1/2, so x plus 1/2 is, did not manage my space very well here, is not a factor. Good, so we've used the factor theorem, used all the space on our board as well. That brings us to the end of our session. If you have any questions, send us a note at info@raisemymarks.com or give us a call, and we're happy to answer any questions you have. Thank you for watching. We look forward to seeing you again.